Welcome to Make Me Data Literate, the podcast that makes data intelligible from the Australian Data Science Education Institute. We're on a mission to make the whole world data literate. I'm your host, Dr. Linda McIver, and every week I'll interview someone with a wild and wonderful relationship to data. Let's see what we can find out. Hello, and thank you for joining us for another episode of Make Me Data Literate. I'm really excited this time to have someone I've been following for a long time in terms of his writing and advocacy work, and I reckon this is going to be a super interesting conversation. So, welcome, Ketan Joshi.
Hi, how you doing?
Good, good. How are you?
Good, very good. Yeah, having some coffee. My nights are getting increasingly sleep deprived. We have a young baby here and a toddler, but somehow still functioning, which is quite nice.
That is impressive. That is very impressive. Those are challenging times, as I recall. So I have a sneaky trick, which is to get you to introduce yourself, because I found it's more interesting that way. So can you tell us who you are and what you do?
Yeah, sure. I'm based in Oslo, in Norway. I'm a full time climate and energy analyst and communications expert. So currently, I work for a sort of Europe based NGO, which helps other NGOs do their communications on climate. But basically, in my other time, I'm a sort of prolific social media user and blogger, covering off pretty much the same issues, but doing it through my own sort of for my own reasons, I guess. And so I have a background in energy. I started off in the renewable energy sector, and then I worked in some government agencies in Australia. And then I sort of wrote a book called Windfall Unlocking a Fossil Free Future, which is published with New South Publishing, which is the UNSW's publishing arm. And then after that, I did a bit of freelance writing, and yeah, now I'm here in Oslo, kind of just on parental leave for a few months. So kind of not taking it easy, but doing some doing the big list of things that I wrote down to so that I would stop procrastinating and do my actual work when I was working. So that's
Well,
me.
I very much appreciate you taking time out of your parental leave to hang out with us today. It's really exciting. I know there's been a lot of data in your career. And one of the things I like to ask, which is a particular bugbear of mine, is how much did your formal education prepare you for that? What did you have to learn that was missing from your formal education?
So my formal education was, high school, and then I did a Bachelor of Science, and I specialized in psychology and neuroscience, and did some really basic statistics. Uh, what I have found is that the most valuable lessons that I've learned are really like procedural and software based, as opposed to being sort of intellectual or mathematical, if that makes sense. So all of the principles of like data analysis and statistics and things like that I learned in university, they play some role, but it's a relatively small role. It feels like everything that I've done basically for the past decade in my advocacy work, using data, has actually been clever little tricks with software, and like data visualization and graphics, and those are all the things that have kind of given me a bit of an edge, in like wrangling data. So it's not even necessarily the creation of a visualization, but also like how to get data, how to extract it from PDFs, which is a huge deal, and
Oh,
also
yeah, it's a nightmare.
yeah, and then just also the habits of investigating data itself. So instead of treating it like a number, like this sort of like magical thing that you assume to be 100% accurate, understanding that it has its own story and its own background, and that all of the baggage that comes with a data set, you're carrying that baggage with you when you recreate it into something else. All that stuff, we didn't really learn it. Like it's all sort of like it's more aligned with the skills of, maybe like a sort of very modern journalist, like the sort of journalists that do like I don't know what the actual acronym stands for. OSINT, OSINT. The sort of like
Yep.
they do like investigations using digital information um, to basically provide an investigative angle to stories. And I realized, much later on in my career that I was actually doing something more akin to that than I was to you know, um, like the stats, the really dry stats courses that you do in university. So
Yep.
I wish that I had that, like I wish I'd had some formal training. But on the other hand, I actually really enjoyed learning all of that stuff on the fly, and then just building up like this monstrous bookmarks folder, just full of like all these little, how to extract data from a screenshot, how to convert a PDF into an Excel file. Um, yeah, and then the one huge blank spot in my career is coding, right? Like I can't code. I can't use I can't use like R or anything like that to create graphics. Um, I've been meaning to, and I've sort of dipped my toes in the water a few times because of people kind of just said to me like, no, it's easy, don't just chill out, it's all good. Um, and then you just drive directly into a brick wall. Like it's not a learning curve; it's a learning wall, and you
Yeah.
just sort of drive directly into it. And you're like, oh, that wasn't fun. I'm not doing that again.
So I had this exact conversation with Alan Duffy a few
Mm.
episodes ago, where we were talking about how if you haven't learned coding as part of your formal education, you can't just suspend what you're doing for a month and learn coding. Like
Yeah.
you've got you've got a job to do and a family and a very busy life. When are you going to learn to code now that you've never learned to code?
Yeah,
It's a
and it's
real blocker.
yeah, and it's the all the guides and the sort of like teaching, like they all overestimate how smart I am and how much I can understand the jargon that they're using. Like I'm kind of like you
Oh,
know
I think that's a very generous way of looking at those things. I don't think they assume a lot of knowledge. I think they come from a lot of knowledge. They have
yeah,
very little perspective on the kind of user who is looking for that information. I
yeah,
have a PhD in computer science, and I can't use
yeah. I
half
mean,
those
like
manuals and things. So it's not you.
this sort of feeds into the way I actually write and create information and advocacy, because I try to come at it from the perspective of somebody who has zero background in the subject matter that I'm talking about, and it works for me because I actually also have zero background in the subject matter that I'm in terms of formal education. Right, like I didn't do climate or energy topics at university at all,
Yeah,
so I understand very much what it feels like when somebody kind of yells the word gigawatt hours at you, and you're like, that means absolutely nothing to my mind. Like I don't know what you're
yeah,
saying.
yeah, yeah.
um, so yeah, and then I read those manuals and I'm like, you don't really empathize with the feeling of not knowing a single thing about
No.
what this stuff is. Yeah,
It's
it's
one
funny.
of the reservations I have with the oft suggested teaching method of getting the kids who are already experienced at coding to
Mm.
teach the kids who are not. It
Mm.
works very badly often
Yeah. Okay.
because the kids who've been coding forever have no idea what it's like to not have been coding forever,
Yep.
and to be having trouble picking it up because they picked it up when they were pretty much in the womb, and so
You need someone who learned it recently. Yeah. You need someone
it's
who had to climb up that wall. Yeah.
yeah, exactly. It's a real challenge. Um, I could stay on that topic forever, but
Yeah.
I should probably keep moving. Is there one thing that you wish everybody knew about data? If everybody knew this thing, it would just make everything a lot better, your life easier, something like
Hmm.
that.
Oh, that's a good question. I think I have to answer it from the perspective of my specialization, which is climate and energy,
Mm,
which is that it's a really fine line. It's this really tense balance between on one hand you've got the side that sort of treats data like it's as if it's almost reality itself. It's so accurate and precise and empirical that it's almost like you're holding the real world in your hands when you have like some data that's been collected about something that happened in real life, right? And then on the other hand, you have the sort of like, I would say probably overly skeptical side, which is basically, you know, someone who has kind of been burned in the past by, you know, they looked at the background or the history of a little bit of data and they were like, oh gosh, this is filled with caveats and like, you know, the little data collecting machine broke down halfway through and like, you know, this is ridiculous. Um, I wish that everybody knew about the sort of constantly evolving and shifting tension that exists between those two extremes, because you often find yourself having to either defend or attack a piece of data because you know it's been assumed to sort of snap to one of those two extremes.
Yeah.
And I find that really exhausting. And it's just like, can we all just accept that this is like just as imperfect a way of describing reality as doing a drawing of someone, and then just kind of like move on? There was a really good analogy that stuck in my mind. There's this guy called Jesse Jenkins. He's an American energy scholar, like one of the best in the world. He's a great dude, and he was describing modeling. So this is, you know, um, I think everybody knows what modeling is, but in the world of energy specifically, what it entails is putting all the information that you have about the current system into a system that kind of like replicates the energy system on in a spreadsheet or in a piece of you know calculation software, whatever they're using. And then basically tweaking those numbers or variables to see what different outcomes happen. So, you know, often you basically just end up with a bunch of scenarios where climate action goes really well and everything gets decarbonized. And on the other end, you've got everything going terribly wrong. And then you've got a bunch of stuff in the middle that has its own, like within that dimension, there are also different things that you can tweak. Like you can have like, you know, suddenly people demand lots of energy because, you know, for whatever reasons, or maybe people use a lot less energy because they like energy efficiency. Um, and so he was describing that, like he was talking about the way modeling has been treated in the past. And, you know, people will treat those as forecasts. They'll go, oh, okay, you know, this modeling said that that's going to happen. So we're just going to act on the assumption that this is the future. Like this is some sort of like prophetic, you
Yeah.
know, time machine that can actually determine the precise pathway of everything that's going to happen in the future. And he's like, no, you should treat it like a map, right? Like when you are walking through the streets and you open Google Maps, you have this inbuilt understanding that what you're looking at is a representation of reality, not reality itself.
Mm.
And then you kind of pick little bits of information like, okay, well, you know, my GPS thing says I'm on this road, and there's lines and shapes marked out on this map that indicate that if I were to walk left and then right, I would end up at my destination. But you're not looking at it being like, wow, you know, they've recreated Earth inside this, inside this little, you know, it's a really pragmatic, sensible relationship that people have with between a map and the physical real world. And I kind of wish people would treat data a lot more like they treat maps, which is that you know you sort of you have a bit of skepticism. You know, you've been like people have been using like Google Maps navigation before, and they've been directed into a brick wall or whatever, and like you know they learnt their lesson. But they didn't stop using maps, right? They didn't say that all maps are shit and that, like, you know, the concept of a map is terrible.
There was no
Um,
point using maps at all.
yeah. So, you know, I think that's really important. And so, one thing, you know, like one thing I've been doing over the past few years is trying to understand which data is really closer to reality and which one is just piled with caveats. So stuff like opinion polling, you know, like asking the population how they feel or think about a certain issue has a lot of caveats, right? Like it doesn't mean it's
Mm.
useless, but you've kind
Mm.
of got to treat it with a lot of care. Whereas something like the measured electrical energy output of a wind farm over the course of a year, of course, that has caveats too, but it's
Mm.
it's different, right? Like it's quite the bounds are a lot narrower on that data, and so it's a tough thing to explain.
Yeah, I used to talk to my students about how no measurement was ever perfectly accurate. The question was always, was it accurate enough for your purposes? And I think that applies to data as well. Like, no data set
Mm.
is ever perfect, but is it good enough
Yeah,
for what you want to do? And sometimes the answer is no. We need to be careful about that.
yeah, and
But
other
you know,
times there's the problem of like overdoing it, like getting like just far more accuracy than you really need. Um, my brother's a scientist, data scientist, working in proteomics in Denmark. And he's constantly sort of yelling at me. Like I'll post something, some analysis, and he's like, "Oh, like, where's your control group? And how come you didn't do all these like SAS tests?" And I'm just like, listen, that was just this tweet. I was just doing like making like a really straightforward point in a tweet, and it would, you know, I don't have the resources to do like a science paper essentially.
yeah, yeah.
So
there,
that's
that
funny.
you do have to think, to look at the what you have available to you, and that's often the data that you're working with is just the data that you can get. It's not the data you actually wanted. um,
Yeah,
but
exactly.
um what are the worst data mistakes you've seen? And I'm differentiating here between mistakes and deliberate misuse, which we'll talk about
Yeah.
next.
um, oh, geez. I think probably the classic example, but probably the most fun example, and also probably the most consequential too, is just when graphics, when charts, like visualizations of data are misused. And it's because, pieces of software like Excel will come with, just like prepackaged options. People very innocently kind of just go for, the most clear looking thing that is available to them.
Yep, choose the defaults.
Yeah. Um, and, there's sort of, there's an example that I think is probably not an example of like an intentional sort of thing. It seems to actually be an accident, which is during the election campaign, the Australian newspaper was publishing polls of various leaders. Scott Morrison and Anthony Albanese.
Hmm.
And the percentages were changing with each one, but somebody traced back what had happened, and some graphic designer had just used exactly the same um, like chart of the previous one of the like 4 or 5 polls ago, and they had just been literally just changing the numbers on top of the pie chart each time.
Oh wow.
I guess that's sort of in the middle range between like accident and sort of being devious, but like um, it was just so like um, it was just very brazen and just sort of like, yeah, okay, we'll just change the numbers on top of the thing, hope that no one notices that the actual values, this areas and angles of the pie chart are not changing at all, despite the numbers
It
changing quite a fair bit.
it's so disturbing that to think that it's possible to get through an entire education without understanding pie charts to the extent that you know the difference between
Yeah.
a 30% slice and a 60% slice, because I saw some of those and they were just so far out that you just had to look at it and go, That's no, those
How?
numbers do not apply to that pie chart."
The other one that I see a lot, and I kind of have to hold my tongue about it sometimes because it comes from people who I know and love and who have just like produced some report or something for like an NGO or whatever.
Mm,
It's like three-dimensional or like overproduced charts. So, when instead of having a bar on a bar chart, they'll replace it with, like a sort of silhouette representation of, like if it's something about if it's data about trees, they'll have a little tree growing as the size of the thing.
mm,
And one of my old jobs, this guy worked there. One of my colleagues, he was like this guru. He was like this like so knowledgeable about like data visualization. and he taught me a lot. And he taught me about the area, the physical size of data visualization is actually can be really really deceptive. If you use thin bars or wide bars on a chart, it can really change the story. It can change the narrative. And three-dimensional charts just completely wreck everything. Right? Like you can, like I'm sure you've seen the pie chart where it's like 3D, but it's
Mm.
been angled up so that one slice of the pie is like right in your face, and the others are sort of obscured at the back,
Yeah,
um, which is just so wild.
that's a really good point because we don't understand the psychology of the way we see things. You need to
Yeah, yeah, and it's really I continue to make mistakes like that. I particularly with uh, particularly with colors. That's my big problem at the moment. Is I know that there's a lot of things that you can do in basic tools like Excel to manage your color schemes. And I just kind of have picked two. Like you'll see this if you look at charts that I've made. It's really I've kind of just picked two or three that I sort of like not even like that much, but I was just like, okay, these are just going to be my style, right? Like these will just be my signature, design. But a few times I've done some pretty bad like red green color blindness crimes in my charts, like made like and then I found this website where you can upload your chart into it to check if if people with red green color blindness can view your chart. Um, and I've been astonished, what a huge proportion of charts I've made in the past are just incomprehensible to a huge to a very decent proportion of people viewing them, because I've used like some horrible combo of like red and something else that they just sort of see as like all grey. So yeah, it's I've started using like more like lines and distinguishing features and things like that. Um, but the thing that I learnt early on was get rid of all the junk, get rid of all the sort of like the noise.
yeah.
Anything that isn't contributing to telling that story, you need to get rid of. Um, and then the other thing I toyed with for a while was using instead of using Excel to create data visualizations, I started using Tableau.
Ah,
Um,
yes.
yeah, which also has a pretty steep learning curve, but once you sort of get over it, it's surprisingly good. I've been meaning to get back into it again because you can do some really cool like animated. You can animate stuff, and you know it feels so cheap. But when you just do like a line chart and you animate it instead of having it as a static image, people are absolutely just wowed by it. They don't understand what it is. It's something about the human visual system. We just respond to movement
Yeah, we
so
really do.
so strongly. Um, and I guess it's also no, I shouldn't be. That's probably a little bit like that's probably underselling it a little bit. Like it's like a chart that reveals itself over this is sort of gradually. So there was one recently um, that I didn't make this, but I shared it, and it was of the cost of converting from coal to gas power and the cost of converting from coal to clean power. So, like hydro, wind, solar, nuclear, whatever. Um, and they had this on a chart, right? Like it's gas has historically actually been quite cheap, and renewables historically were quite expensive, as you would assume, for a new technology and an old technology. Um, Gas, of course, also being so heavily subsidized by governments in extraction and use. And then, of course, COVID happens. Supply chain restrictions happen. Warm weather impacts on production facilities around the world, and that's resulted in from about mid 2020 onwards, there was a huge drop in the price of oil and gas due to a big reduction in demand. and then that swung way upwards. So you've got this animated chart of like cost of cost of converting from coal to gas is very low, and a little bit higher as coal to clean. And then 2 years ago, it sort of intersects and switches, and then the cost of converting from coal to clean goes down because renewables have been getting cheaper. And the
Mm.
cost of converting from coal to gas just, it's one of those like animated charts that just skyrockets in the last frame. It just punches you in the face in the last frame because you're like, wow, geez, this is incredible. And yeah, it was just such a dramatic use of an animated chart where if it had been a static image, you would have looked at it and been like, okay, you would have kind of gotten it all in one hit. Whereas this is more of like a journey, um, which I really liked.
So I guess it's telling the story, but in a visual way.
Yeah, literally a time series, right? Like except accelerated. Yeah, it's a video really.
Mm.
It's a sort of short film. No, that's too generous. But yeah, it's cool. I like it. I need to get into that. But yeah, I'm sure I'll make plenty of mistakes with that sort of stuff too.
I mean, you don't know what traps there are until you trip over them, really.
Yeah, yeah, exactly.
Have you ever seen data deliberately misused?
Mm. The deliberate misuse of data is basically what kicked off my career as it is today, right?
Oh,
I started off my job in 2010 as an analyst at this wind energy company that used to be called Infigen. It's now owned by Iberdrola, which is a Spanish wind farm company. And they were setting up a bunch of new wind farms in Australia, and they had absolutely no idea what to do because not just because they had not really set up many new wind farms recently, but also because the grid operator was just like, we don't know how to treat these things. These are very strange, new, like variable. um, they actually, everybody did pretty well. We set up an entirely, completely new wind forecasting system that uses like really advanced localized wind forecasting tools to be able to predict what the output of wind farms is going to be over the next sort of 24 to 48 hours. Obviously, the error bars get wider and wider as you get more into the future. We did a lot of market analysis and analysis of wind farm output and performance. Like we did a lot of we wanted to obviously like the company wanted to know how well its own wind farms were doing, but also we wanted a picture of like how the whole grid was operating, right? We wanted to know if this was really feasible. So we learned a lot very quickly about the operation of wind and solar in the power grid. And it was also at that time when the issue became deeply politicized, very profoundly and very prominently in media. And so what you would see is, someone would be like, um, there was a blackout in this particular area. And, like I'm obviously thinking of South Australia, but
yeah.
it happened actually many times before that, before 2016 as well.
Mm.
Uh, and they would then pull up some data, like they would have a friend, who worked in energy markets or something, or they would have access to some website, and they would pull up the energy data and they would look at the output of wind farms and go, oh, okay, well, this matches with that. And, like that would just end up in the newspaper, right? Like they would give it to some like graphic designer at the Australian and they would have a thing saying, wind farms cause blackout. When of course, when you know the real story, of course they didn't. You know that
Yeah.
just because two things happen at the same time, they might be causally related, but they're not necessarily causally related. And in many cases, of course, they weren't.
Yeah.
And so, another example that really stuck in my memory is sort of around 2015, 2010 to 2015, there was like a sort of health scare, I guess you could call it, around wind farms, which I wrote a bit about in my book. If you remember the wind turbine syndrome stuff, which
Yeah.
I think people forget how prominent that was in like media coverage of renewables and political discourse on renewables. It was a really big issue, and it kind of set the stage, for a lot of the stuff. And what happened is there was this study that came out by this acoustician who was kind of known to like assist the sort of anti-wind groups and anti-wind side. And I read his study, and what he had done is he had collected like I think it was like 600 to 700 symptom reports from people living near a wind farm who were sort of opponents of the wind farm. And he collected all those reports and then collected wind farm data, just from a public source. And I looked at it and I was reading it and I was like, none of these symptom reports match. They're basically just random, right? Like relative to the output of wind farms.
Mm.
Um, uh, and he got asked about it, and he's just like, yeah, no, he's like, I just picked the ones, I just picked the instances where they matched. He's like, I picked
Ah!
the ones where, I picked the instances where people reported symptoms that matched the wind's output, and he totally believed that that was actually what the purpose was. He's like, no, no, no. I was just finding the ones that matched because then that shows that that the wind farms are causing the
Oh, wow.
symptoms. And he's like, why? Like he was baffled as to why he was being asked. He's like, this is what you're meant to do. You get all the data and then you find the ones that match and then present the ones that match and go, oh look, this is where the wind farms were causing.
Oh,
So
wow.
not an amazing piece of analysis, but also used very very prominently, right? Like that was kind of used in like parliamentary hearings and like it was like sort of like this is the smoking gun kind of thing. And
Mm.
of course, what are we now? Like 7 years later, the whole issue has kind of faded off into nothingness.
Yeah.
But the whole idea is that it kind of just creates this roadblock. Um, and a lot of it was based off really faulty data. So these misinterpretations or like intentional deceptions are really have a very significant consequence. And with energy, there's a lot of open data out there. A lot of it's publicly accessible, and so people, basically, with like a sort of semi capability of understanding this, will apply the wrong framework or the wrong understanding to it.
I could honestly talk about this and with you all day, but I'm aware that you have time constraints. So let's cut to the final question. What excites you about data? We've talked a lot about the issues and the problems, and I would actually like to get you on another time to talk about how more about the way that seeing data misused got you into the things that you do
Mm.
now. But for now, what is it that excites you about data?
Definitely just access to a bit of a secret story that just is probably not uncovered by someone else. Uh, it's also very therapeutic. The process of just focusing really narrowly on a single thing to acquire. Um, Something I've gotten into really recently is like forecast comparisons. So when you have like some government body or whatever that puts out a forecast every year or something, going through the history of those forecasts and then comparing what those forecasts are to reality. And that tells its own story, a story about like the hearts and minds of the people who were responsible for creating those forecasts. Um, and it's just such a nice example of what I find to be exciting about data analysis because you sort of get a very human and like a very sort of flawed but fascinating and really rich story about like what people, how people think about a challenge or a topic. Um, like Australia's emissions forecasts, when you look at the history of those, like it's just like this incredible story of a total failure to understand the growth of renewables and um, this sort of like false narrative now of like look how much we've changed in terms of like loving renewables now, which is what the previous government did before the federal election. And so yeah, it's just fun. It's just so much fun to piece all that apart. And then also a huge part of it for me is packaging it up into something really digestible and understandable, and then just the sheer joy of sharing that with people, like when you post it or when you send it or we include it in an article, and people just react strongly to it. They like they say stuff like, "This is a cool chart" or "This is interesting data." I can't even begin to describe how happy that makes me, because it's something that you've labored with, if you put effort into it, and it just brings me so much joy. I know it's silly, but like, it brings me so much joy when people say that they got something out of it. They're like, "Oh, this changed the way that I think about a particular issue." There's one I created recently of a visualization of, it's not actual like real world data, but it's just sort of illustrating a mathematical principle, which is that when you look at emissions, people often talk about the 2050 target, but the pathway you take there can be really slow. Like you can do nothing and then 2040 just rush to reduce all your emissions. You can take a straight line there, which is kind of the Labour Party's approach, or you can reduce emissions a lot now and then kind of have like a sort of flatter curve out to 2050. But of course, the damage from climate change comes from the adding up of emissions, not from your yearly sort of like constant.
Yeah.
It's pouring stuff into a finite space, right? Like the bathtub is filling up. And so if you take the really slow approach, it's about 3 times as worse as taking the really fast approach, even though you end up at the same spot of net zero by 2050. The speed at which you get there, it decides how much we suffer from climate change. So I created this graphic to show that, and people were really they said really nice stuff about it, and I was just like, yes, thank you. Like, of course, communicating about climate change is important, but I was just like, I also very highly value when people say nice stuff about it
I,
because it just
I
feels so good.
totally get that.
Yeah,
It does.
yeah,
And the feeling that you've made a difference, that you've changed someone's perspective on something, or that they understand something they didn't understand before, that's golden.
it's
That's
a thrill.
glorious. I love that.
Yeah.
Yeah, it is. It's an absolute thrill.
Hmm.
What a beautiful point to end on. Thank you so much. It was wonderful talking to you, and I hope we can do it again sometime and go a little deeper. It was just I really appreciate your time and generosity.
Yeah, no worries. No, I really enjoyed the chat, and thank you so much for inviting me. Good to be here.
Thanks for listening to Make Me Data Literate. You can support the work of the Australian Data Science Education Institute at givenow.com.au/ADSEI. Tune in next time for more conversations with amazing data experts.